Good day everyone, my name is Tobilid of ECE 3A and today I'm going to present to you my performance task number 2 in ECE 23. The discussion for this performance task will cover line coding schemes, and 8B60 operation. Now, what is line coding? Line coding is a process of converting binary data to digital signal. It is also a method of placing digital signal on a wire. It specifies the relationship between the binary information in a data bit stream and the square wave voltage variations in the wire that represents this information electrically. Line coding also refers to the process of converting digital data into digital signal. Whenever we transmit data, it is in the form of digital signal. So with the help of line coding, we can convert a sequence to bits into a digital signal, which then again converted into bits by the receiver. So as previously learned, line coding schemes falls into 5 major categories. First, we have unipolar, and under that is NRZ, which means non-return to zero. Second is polar, and under that we have NRZ, RZ, and biphase. Under biphase, we have Manchester and differential Manchester. Third is bipolar, and under that we have AMI and pseudo-ternary. Fourth is multi-level, 2B1Q, 8B60, and 4D PM5. And last is multi-transition MLT3. Now, what is 8B60? 8B60 simply means 8 binary, 6 ternary. 8 is the length of the binary pattern, B is binary data, 6 is the length of the signal pattern, and T is the number of levels in signaling. Excuse me. 8B60 is one of the most common block coding methods. It is also a signal encoding method used in 100 base T4 fast Ethernet standard. So to give a little definition, 100 base T4 is the early implementation of fast Ethernet over twisted pair cables carrying data traffic at 100 Mbps in local area networks. 100 base T4 uses 4 pairs of category 3 unshielded twisted pair wires, and the maximum transmission distance is 100 meters. 3 pairs of line are used to transmit data. Now, the signal of 100 base T4 adopts 8B60 coding method. That is, every 8 bits are converted into a group data every 6 bits, and the ternary code group is set every 6 bits. Now 8B60 means send 8 data bits as 6 ternary signals. So in this type of line coding schemes, the incoming data stream is split into 8-bit patterns. Each 8-bit data pattern with 2 voltage level is examined. This 8-bit pattern is then converted into a 6-bit pattern but using 3 voltage levels. We have negative volts, 0, and positive volts. So each 8-bit pattern has a unique 6T code. For example, the bit pattern 00000000 uses the code positive negative 00 positive negative, and 00001110 uses the code negative positive 0. Next slide. Sorry. Here I have the basis for our binary and their corresponding signal elements. This is our table that we are going to use in the future discussion. Now 8B60. The idea is to encode a pattern of 8 bits as a pattern of 6 signal elements, where the signal has 3 levels. In this type of scheme, we can have 256 different data patterns and 729 different signal patterns. So all in all, we have 473 redundant signal elements that provide synchronization and error detection. Part of the redundancy is also used to provide DC balance. Each signal pattern has a weight of either 0 or +1 DC values. This means that there is no pattern with a weight -1. Now, what if there is a situation where we'll encounter two groups of weight 1? If the two groups of weight 1 are encountered one after another, the first one is sent as is, while the next one is totally inverted to give a weight of -1. Here, the following figure shows an example of three data patterns encoded as three signal patterns. The first 8-bit pattern, 00010001, is encoded as the signal pattern negative, 0, negative, 0, positive, positive, with a weight of 0. The second 8-bit pattern is 01010011, which is encoded as negative, positive, negative, positive, positive, 0, with a weight of +1. Now, the third bit pattern should be encoded as positive, negative, positive, 0, positive, with a weight +1. So in this part right now, we have an imbalanced DC. So to make it balanced, we have to invert the pattern. So from this type of signal element, we are going to convert them from positive, negative, negative, positive, 0, positive. It's going to be negative, plus, plus, negative, 0, negative. So it's going to be encoded as negative, positive, positive, negative, positive, negative. To create DC balance, the sender inverts the actual signal. The receiver can easily recognize that this is an inverted pattern because the weight is, take note, -1. The pattern is inverted before decoding. So that's all today for our discussion, and I hope you learned how 8B60 line coding scheme pattern works. That's all. Thank you.